Welcome. Today I will solve 3 questions where a cable is attached to some block, some body or rectangular block. Purpose of the cable is to prevent the motion. Now, these 3 questions I will solve this class. Same 3 questions, next class also will be there, second round. See, here the cable is horizontal. Next class, I will make it inclined. I am limiting to 3 questions per class now. See, question 14. A block weighing 20 kilonewton, see, this block is of weight 20 kilonewton, is placed on a rough horizontal surface and a force of 6 kilonewton is applied. Oh, I wrote 6. Then when I wrote 5 here, 5 kilonewton, okay. A force of 5 kilonewton is applied as shown in figure. See, you are applying a force of 5 kilonewton. Next, full stop. The person who said the question, he thought if you apply a force of 5 kilonewton, question is set by me only, so don't blame me later. He thought that, even I also thought, but actually I know it, okay, that a block will not move. Okay, he thought that by applying 5 kilonewton, this block will move. Now, how to prevent the moving? See, you imagine here, see, this is a cable. He is applying a force this way. So, block will move. When the block moves, this cable will prevent it. Therefore, then, full stop, see here. See, new sentence. To prevent the block from moving to right side, a cable, red color cable, is attached as shown, a cable. Coefficient of friction for contact surface is 0.4. Find tension in the cable. Very, very simple question, but very interesting. Those who are interested in concept solve, this is very interesting question. 1 minute. Some color problem. Okay. Just a minute. Colored pen got mixed up, that's why. Okay. Now, class. Something I will tell in the class. Those who want to learn the subject, see, these questions all will make your concept very clear. Correct understanding will come. See, write everything explained in the class and also dictated in the class. Some statement I will dictate, something dictation is not required. What all I tell you should write if you want to understand. Now, question is, if you apply a 5 kilonewton load, purpose is to see, the person who said the question thought it will go to right side. See, this question 5. Next question 14, 15, same question. I will not explain once again. All today's 3 questions, same explanation. Now, to prevent it from moving right side, cable attached here. Okay. So, when you move this way, if it moves, the cable will be in tension. This is all I told you. See, when it moves this way, the cable will be in tension. Okay. Now, how to solve the right here? How to solve the question? There are two types of solution possible. First, I'll give systematic and perfect way of solving. Then I'll give you alternate solution where directly in one step you get the answer. See here, 2 stages. Here, 2 stages. Second stage, if required. You write here. When I solve from basic principles here, first stage, then you write if required, second stage. Here not that way, directly in one stage. See, what we will do is consider the block without the attached cable. You imagine cable is not there. See, you imagine that cable is not there. And replace that 5 kilonewton force by a force P for which the block is on the verge of moving to right side. See, you remove this cable. No, right here, cable is not there. Then 5 kilonewton is applied load. Then what we want to know is whether that 5 kilonewton force will move the block or not. How to know it? This we solved last time. Replace this 5 by an unknown force P for which the block is on the verge of moving to right side. Okay, now I told so many times further statement you should write. Therefore, when it is on the verge of moving, it is a case of limiting friction. Now you should write. I am not wasting time. Let R be the normal reaction, frictional force. See, when you try to move the block to right side, see, by a force P, frictional force will be left side, limiting frictional force, mu into R. In the question given, mu is 0.4. That all, there is no space in the board to write. You should see, refer earlier question. I told there. You write all the statement. It's a limiting friction case because the block is on the verge of moving. So, therefore, at the state of limiting friction, R is the normal reaction. Frictional force is mu times R. Mu is given 0.4 right there. Given coefficient of friction is mu 0.4. And frictional force, limiting force is mu into R is 0.4 R. Okay. Now, solve the question. Sigma Fy 0. R minus 20 0. R equal 20 kilonewton. Sigma Fx 0. Plus P minus 0.4 R equal to 0. P will come 8 kilonewton. Now, class, write everything I tell now. So, if the cable is not there, you write here. If the cable is not there, simply block is placed on a rough surface. It is on the verge of moving when the force reaches 8 kilonewton force. But the applied force is only 5 kilonewton. That means this block will not move. This block will not move. So again, write everything I tell. This you should write here. I am not writing. Therefore, see, since the force required to move the block or the block is on the verge of moving, when the force reaches 8 kilonewton, but actual applied force is 5 kilonewton. So, when you apply 5 kilonewton force, the block will not move. Now, when the block will not move, see here. Suppose you take a member, put a cable, okay, attach a cable. If the block is not moving, cable will be lying idle. See, the cable will become active only when the block starts moving. Remember, cable will become active only when the block starts moving. Or imagine you are standing here. Somebody from backside is holding your shirt. See, your shirt. He is holding little projection of shirt. If you are not moving, he is just holding your shirt. But suppose you go further, then he will pull you back. See, the tension will come then. See, then the tension will come. So then the cable will pull it back. See, I told you cable will pull it back means cable is in tension. This is all I explained for you. Therefore, no tension in the cable, that is T equal to 0. You write here, no tension in the cable. Question is, find the tension in the cable. So write here, let T be the tension in the cable, T equal to 0. This is perfect solving. Now, alternate, see, now do one thing. See the question, direct, don't see here. Do not see anything here. Alternate solution, direct. See here, our question got over only in one stage. Second stage will come if it moves. It is not moving, so second stage will not come here. Direct solution in the class, see. Let us assume that given force of 5 kilonewton will result in the motion of the block as per the question, right here. As per the question, see, the person who said the question, as per question. See, what he told in the question? To prevent the block from moving to right side, a cable is attached as shown. So he thought that, I only thought, I know it is not moving. I am solving variety of questions. So let us assume that the given force of 5 kilonewton will result in motion of the block to right side as per question. Okay, then. Now, because of the attached cable, this motion is prevented. See, if you apply 5 kilonewton this way, if you think the block is moving to right side, the tension in the cable, this I explained last time very clearly. Now no one should ask, sir, why tension this way? See, the cable will be tension. See, if the block moves, ink bottle. See, actually, the ink bottle. Okay. See, if the block moves, the cable will be in tension. What cable will do? It will pull it back. Therefore, cable will be in tension. Let T be the tension in the cable. Okay, now, once again, see, the block will overcome the friction. The force has to overcome the friction. It will reach limiting stage. So here also, see, block is not moving. See, when you apply tension T, it will prevent the block from moving. Therefore, once again, limiting case. See, till this block starts moving, cable is idle. So when the force tries to move it that side, that is when it overcomes friction, then tension in the cable is left side will come, and limiting friction, FF limit is 0.4 R. Solve here. 5 kilonewton T 20 R. Sigma Fy 0 plus R minus 20 0. R will come plus 20 kilonewton. Sigma Fx 0 minus T minus 0.4 R plus 5 equal to 0. Substitute R equal to 20 kilonewton. See there, T will come minus 3 kilonewton. Oh, not possible. My cable tension is minus 3. That means, you make a note, what is the meaning of minus 3? Instead of pulling it back, it has to push it. No cable can push it. See, no cable can push it. Or simple language you can tell, we assumed that the block will move. To prevent the block from moving, the tension will prevent it. But negative came, negative indicates that the cable is not active. It is not 0 also, say, it is actually 0. Therefore, right here, negative sign indicates that the cable is not required. Actually, instead of left side, it has to go to right side. Because, reason why, see, 5 kilonewton here. You see the answer here, 8 kilonewton. So, to move, you require 8 kilonewton. Applying 5. So, your cable has to push it this way by 3. Cable cannot push. Cable can only pull back. I told. A cable cannot take tension compression. Or negative, you took T as tension in the cable to prevent the block from moving. Negative sign indicates that cable will not be in tension. It is not compression minus. The tension minus 3 means later in strength of material solve, it becomes compression 3. No, here not that way. Our purpose of tension in the cable is not there. Negative minus means what? It is not required. Therefore, write here tension minus 3. After class, you write here class. Negative sign indicates that the cable is not required. See, you don't require it. Therefore, finally write tension in the cable equal to 0. This is question number 14. Now see, something I wrote there, that is my solution. Don't see there. These numbers don't see. Okay. See, what all I wrote here, don't see that one. That's I solved everything. Okay, now, question number 15. 15. Same question, a force of 8 kilonewton is applied. See, 8 kilonewton. Okay, solve the question. 1 minute. Now, solve this question. Second question. Same argument. 8 kilonewton applied. So, therefore, first solution, you imagine that replace that 8 by a force P. Solve and get the value of P. See, consider the block without attached cable and replace that 8 kilonewton force by a force P for which the block is on the verge of moving to right. Again, same statement, write the same statement. What happens? So, P will come 8 kilonewton. Okay, now write, note, class. Again, write what I tell. The force required to move the block is on the verge of moving when the force applied is 8 kilonewton. Okay. And actual force applied also is 8 kilonewton. So, the given force of 8 kilonewton is exactly equal to the force which will make block on the verge of moving, still not moved, on the verge of moving. Therefore, again, tension in the cable equal to 0 because cable is still idle. See, if you are standing here, if somebody is holding you back, if you move, he will prevent you. You are about to move, he will not pull you back. He will pull you back when you start moving. So this is on the verge of moving. So again T equal to 0. Okay. Or alternate solution, do the same way. Now do one thing, apply 8 kilonewton load. Solve 8 kilonewton. What I told just now, solve the same way. Actually that is for next question. See, this all I wrote for next question. Okay. Same way solve. Finally, see, when you substitute and solve here, this is 8. Your T will come 0. It will come 0. Oh, correct, everything correct? Any corrections? Did I write anything? Replace 8 kilonewton? Yes, 8 is okay. R minus T, R minus 20, 0. You got R 20 minus T minus 0.4 R plus 8, 0. Substitute R equal 20, T will come 0. Right, in the class. T equal to 0 means tension is not required. But last time negative came. Last time it will be reversed. No, not that way. Reverse is required. So this time T0 means the applied force applied force will result in the block being on the verge of moving. Therefore, tension equal to 0. Okay. Now, question number 16. Same question, not 8 kilonewton, 15 kilonewton. I think some people will tell, sir, we know the answer. How much? 7 kilonewton tension. Correct. Tension in the cable is 7 kilonewton. Correct. But now you have to solve systematically. See here. Class, write everything I told in the previous question. Same statement. Consider the block without the attached cable and replace that 15 kilonewton. See, it is 15 kilonewton. New question. Replace that 15 kilonewton force by a force P for which the block is on the verge of moving. Class, limiting case, see, P, etc. Your P will come 8 kilonewton. Now write a statement here, see. Now class, statement required. The block is on the verge of moving when the force, this force P reaches 8 kilonewton. But applied force is 15 kilonewton. Oh, this time the applied force is more than the force when the block is on the verge of moving. Therefore, this time the block will move. So to prevent the moving, cable is required. So this time tension in the cable will be there. See, you move by 15. But see, on the verge of moving, when the force is 8 kilonewton, it is on the verge of moving. But you are applying how much? 15 kilonewton. That means the block will move. Therefore, tension will come. Again, right here. Now, see what to do. So, second stage will come now. See, now, P 8 kilonewton. What all I told you should write. Since the applied force, see, right here. Your P, see, yeah, but applied force, see, applied force is 15 kilonewton, which is more than that 8 kilonewton. What is 8 kilonewton? Right here. 8 kilonewton is when the block is on the verge of moving. But when you apply 15 kilonewton, block will move. Therefore, block will move. Block will move. Right. Now, right, to prevent the block from moving, apply the tension. Right. One more, see, one more sketch you have to write. Okay, do one thing now. I can do one thing now. I can see here. Okay, now apply 8 kilonewton force. See, don't see there. Don't see there. Apply, see, from here, those who are serious should do what I tell. Write this sketch. Applied force is how much? 15, right here. Applied force is 15 kilonewton. Don't see that one. 15 kilonewton. Tension in the cable is T. Solve it. When you solve, your tension in the cable, see, plus R minus 20, 0, R20 minus T plus 15 minus 0.4 R, your T will come plus 7 kilonewton. Therefore, right here, tension in the cable is 7 kilonewton is the answer. Okay, this, see what I wrote here should come here. It should come here. Okay, then, one thing. Then, once that is over, alternate solution. Don't see this one. Alternate solution, do not find what force is required to move. Directly apply 15 kilonewton and mark tension T. Because as per the question, he told what? To prevent the block from moving, apply 15 and apply T. Solving, you get 7 kilonewton. So this direct solution is stage 2 of this question. Here what you do? Here first you find what force is required to move the block, or when the block is on the verge of moving, 8. Oh, applied is 15. So therefore tension will come. When tension comes, this sketch should come here and finish the question. And when I go for alternate solution, that sketch should come once again. See what I tell, that way you solve. Okay, now this question 16 over. Now I will solve question 17, 18, 19. No, not now, because 17, 18, 19. Actually, I will be out of station for few days. So I am recording now so that I can upload at least 2 or 3 classes when I am out of station. So tomorrow is Friday. Tomorrow I will upload 1 class, Friday, Saturday and Sunday. Monday I will not be uploading. So now, okay, I will go to next, I will continue in the next class, but next class also same type of questions, but cable is inclined to understand more. Okay, we will meet in the next class. Thank you.